Question is about the element iodine and its compounds. Iodine's in group 7, so it's got 7 electrons in its outer shell. Complete the electron configuration of an iodine atom. Well, you find it in the periodic table. It's in period, or row number 5, so it's going to have 5s2. So it's going to have a krypton core, or krypton electronic configuration, plus it's going to have 5s2. And then it'll have 4d10, so it'll fill up its outer shell as it goes across it, fill up its d shell rather with 10 electrons. The 4d shell will fill up, and then it'll have 5p5. So it'll have 7 in its 5th outermost energy level. 2 add 5 is 7, and it'll have 4d10, so it'll have a full 4d underneath. Part of the structure of iodine crystal is shown in figure 1. Use your knowledge of structure and bonding to explain why the melting point of iodine is low and why that of hydrogen iodide is even lower. So if you have a look at the iodine molecules, they seem to be packed close together, but there seems to be, if these are the iodine atoms, they seem to be in pairs. And that's because iodine's in group 7, wants to gain an electron, and so 2 atoms come together and share an electron in a covalent bond. So first of all, the molecular. Molecular means that the small molecules covalently bonded to each other. And with no dipole, no electronegative atoms in there, so no delta plus and delta minuses, there's just going to be weak van der Waals bonds between them. In hydrogen iodide, H is in group 1 and iodine's in group 7. H wants to gain 1 electron or lose 1 electron, gain 1 or lose 1, and iodine wants to gain 1 or lose 1 as well, and so they will share in a similar fashion. So the first 2 marks are for saying that iodine is molecular, has a small number of atoms joined together, 2 atoms joined together, in actual fact I2, 2 atoms joined together with a covalent bond, and similarly hydrogen iodide is molecular, it's got H and I bonded together with a covalent bond, because each of these atoms wants to gain 1 electron. The next stage for the next 2 marks is to talk about the intermolecular bonds. We've already said there's no delta plus and delta minuses, there's no polar bonding, no polar bonds within the actual molecules, and therefore there's no dipole-dipole attractions between the molecules or any hydrogen bonds between the molecules. It's all van der Waals forces. So there's the intermolecular forces are van der Waals forces in both iodine and hydrogen iodide, and they're weak, so the melting points of both of them are low. So the final part is, why is iodine higher than hydrogen iodide? And that's because iodine atoms are larger. They're larger, and so they have more electrons, and so they have more van der Waals bonding. So they've got more stronger van der Waals bonding between the molecules in iodine, just because they're larger. So more energy is needed to break these van der Waals bonds, and that's why it's got a higher melting point than hydrogen iodide. Actually, for the 6th mark, you might mention that hydrogen iodide has actually got slight delta plus and delta minus. It does have slight polar bonds, and therefore it will have slight dipole-dipole attractions in there, but they're not as large as all of the lots of van der Waals forces in iodine, and so the overall effect, the higher melting point in iodine, is due to the fact that iodine atoms are much larger than the hydrogen atoms in hydrogen iodide, and therefore there are very, very many more van der Waals bonds. Suggest why iodine does not conduct electricity. Well, electricity only conducts through a material if it's got delocalized electrons, so it's got no delocalized electrons, it's got no moving electrons in there. Deduce the equation for the formation of hydrogen iodide from its elements. So hydrogen is H2, iodine is I2, so H2 plus I2 makes 2Hi, or you could have half H2 plus half I2 goes to Hi. Triiodide ion is formed when an iodine molecule, that's I2, is bonded to an iodide ion, so that's an atom that's gained an electron. An iodine atom wants to gain 1 electron, so if it's going to form an ion, it's going to be I minus. So an iodine molecule is I2, an iodide ion is I minus, I2 and I minus makes I3 minus. So This triiodide ion is I3-. Ammonium is NH4+, so it's going to be NH4+, and I3- is going to make NH4I3. So your answer is D, this one here. Deduce the shape of IF3 molecule. Well, I've drawn it for you here, and the shape of an IF4- ion, and I've drawn that for you here. We can talk through this now. So an IF3 molecule, I is in the middle. IF3, what's iodine got? Iodine has got 7 electrons outer shell. If it's bonding 3 Fs, each that want to gain 1 electron, it's going to form 3 covalent bonds, which will take 3 electrons. So out of the 7 electrons outer shell, 3 are involved in 3 bonding pairs, and leaving 4 electrons or 2 lone pairs left over. The 2 lone pairs repel as far as they can go away from each other, leaving the 3 Fs in a plane, in a trigonal planar shape with a bond angle of 120. These are the lone pairs up and above, or you can just draw them as 2 dots. IF4-. So iodine's in group 7. If it's a minus, then it's got an extra electron, so it's got 8 electrons in its outer shell. If it's got 4 Fs, then that's 4 bonding pairs. From the 8 electrons on the iodine now, 4 are involved in bonding pairs, and there's 2 lone pairs, 4 electrons left over, 2 lone pairs of electrons, which will go up and down and repel the furthest. It will leave the 4 Fs then in a square planar shape, bond angle 90. You can put a square bracket around the whole molecule and a minus, because we're not quite sure where the minus charge lies. Deduce the oxidation state of iodine in the following species. So I've put spoilers here. Ba is in group 2, so that's 2. I've got 6 O's in there. O's are in group 6, so they're -2 oxidation states. They gain 2 electrons, so they're O2 minuses. There's 6 O's, that's -12. -12 and +2 for the Ba2+, that's lost 2 electrons, is -10. So -10 something, and there's 2 I's, 2 somethings equal -10. 2 + 5's equal -10. Let's have a look at this one. H4iO6-. Well, H's are 1+ each, that's 4+. 6, 2 minuses, 12- and 4+. That means the I is in 8, except that it's got 1 electron left over. So if it were 8 in +8, then that would be 0. If it's in +7, then it leaves 1 minus left over. So the I is in +7.